Hi, 7th graders. We're going to go ahead and start our last chapter for this year. We're dealing with section 12.1 today, which is variables and expressions. You've heard these terms as we've talked about things throughout the school year, and we've defined them, but now we're going to really concentrate on them and review here. Okay, so the first term we have is called the constant. And a constant is a specific real number that never changes, or it is called a fixed number. It is the same. So some constant numbers would be 37 and pi. When I say I want the number 37, you're going to instantly know the number 3 and a 7 when we put it together is 37. You're not going to write 04. Okay, it will not change. It will always stay 37. Just like pi, when we talk about pi, pi is pi. Okay, it cannot change to something else. So we call that the constant. We have then variables. Variables are letters that are used to represent a quantity. Okay, that can change in value because at this point we don't know the exact value for the variable, and so we put a letter in place of that until we find out what that quantity is going to be. So a variable in a sense can be a placeholder if you want to think of it that way. We tend to use letters to represent those, and so we use X, Y, Z, any letter that you want to name for that space, okay? Then we have these two types of expressions, okay? We have what is the algebraic expression. It's a mathematical phrase or expression that uses one variable at least, okay? That's where we get an algebraic because it's using a variable to it, okay? So here I've got two different examples. I have x minus 3. It's an algebraic expression. It's saying take this unknown, x, and subtract 3 from it. Here we have 3y plus 15. These are both types of algebraic expressions. Then I have what is known as the numerical expression. And it's simply a mathematical expression that uses constants and operations. So if you notice, there are no variables in here. Okay, we know the numbers. We just have to go ahead and simplify it and work with it. Okay, I have plus, I have addition, I have subtraction, I have multiplication, I can do division. It's any operations that uses constant numbers. Okay, so we're going to go ahead and work with these today and know how to use it interchangeably here. Okay, one thing, if you've noticed as we've gone through the year, as we moved more into algebra, we tend to use less symbols. And so you need to get comfortable with seeing when I have a 7 stuck right next to the letter M, this means it's multiplication. We're really saying 7 times M. Okay, we're not putting in that multiplication sign because as we do algebra, our problems tend to get longer and longer. And so we try, in a sense, to save space and keep it uniform so that you know what the different symbols mean, okay? Because in elementary, you're used to using an X for multiplication. Well, that can get very confusing when we're using variable X. So we try to keep things simplified. So when we put numbers side by side here, that means multiplication. Okay, so we're going to practice here. Okay, I've got two algebraic expressions because they both have variables here. And I want you to be able to tell me what is the constant and what is the variable. Remember, our definition for a constant is a specific real number that never changes. And a variable is a letter that represents a quantity. Okay, so looking at this, the constant is -3 and my variable is h. Okay, here my constant. What is my constant that is not going to change? Here's where it's a little tricky. The number that's not going to change is my 13. These all have variables that are attached to it, and so my number is going to change depending on what is put in place for these variables. Okay, so we need to be able to realize which ones are constant and which one is going to change. This 7 in front of this, and really it's a -1 in front of the n, are what we call our coefficients. It is the number that is attached in front of our variable. Okay, so With algebra, we need to get comfortable to change and work with words, our expressions written out in Word, and being able to put it in a algebraic or numerical expression without those words. So we're going to practice that here, okay? So here I have Mandy has 6 more books than Jeff, who has 8. Okay? Now, some people in their thought process would think this through and look at the problem and say, okay, Mandy has 6 more books than Jeff. So plus 6 more than Jeff. Okay, that's a good start. It gets us thinking what we're talking about. Then at the very end, it says more than Jeff, who has 8. So we can go ahead and we can substitute this J for H. For 8. And so now we've turned this into a numerical expression. 8 plus 6 represents how much Mandy has of books, okay? And so we've taken what was a word form and put it into a numerical expression, okay? We're going to do the same here for this, okay? Here I have the problem that says Bob has 3 times as many stamps as Bryson has in his collection. So Bob has 3 times as many stamps as Bryson has in his collection. Well, did you notice it? It doesn't tell us how many stamps Bryson has. We have no numbers confirmed yet. Okay, so because we have no absolute numbers, we're going to have to write a variable expression here. Okay, and so we're going to have to use a variable to represent how many stamps Bryson has. Now, we can choose any letter to represent that. Some people might choose S to represent stamps. Some people might choose B to represent Bryson. Some people might just go with the numerical N to represent number. It is your choice. The thing is, you need to be able to tell your reader here. So here we chose S. S for stamps. And so if you noticed over here to the right, I said what my letter represents here. S stands for the number of stamps that Bryson has, okay? Now let's go to our problem. And our problem says Bob has 3 times as many stamps as Bryson. So Bob has 3S. We don't know what Bryson has, and that's okay. But I can write an algebraic expression to represent the situation that's being talked about. Okay, let's go ahead and do this one here. Reggie is 7 inches taller than his younger sister Jill. Okay, so do we know how much his younger sister is? No, that doesn't really matter. So let's go ahead and use S for sister. Okay, so Reggie is 7 inches taller than his younger sister Jill. So I'm going to let S represent, S stands for sister Jill. Her height. Okay, we know specifically what it's talking about. So, and now I'm going to finish up the problem. Reggie is 7 inches taller. Okay, so right there is my algebraic expression from this word statement up above. Okay, be very careful. Subtraction and division gets a little complicated because you've got to put them in the right order. So be very careful when you turn and put your algebraic expressions for subtraction that you're getting them in the right order. Okay, now we're going to take a look here, and we can also evaluate algebraic expressions. So at one time we did not know what J could represent. But later on, we find out that J really represents 65. So we can go ahead and evaluate this algebraic expression now that we know what J is. And that's called evaluating. Okay, so I'm going to evaluate J plus 7 if J is 65. So to do this, all I'm going to go ahead is substitute. Instead of J, I'm now going to put 65. So 65 plus 7, I can go ahead and finish my math and realize that equals 72. Okay, I'm only allowed to do that because I was told now what my variable J represents. Okay, so let's go ahead and let's do some practice here. Let me move things forward here and get a clean slate. Here we have some algebraic expressions, okay? And now it's telling me to go ahead and solve for them, and for every n, my n represents 6. So all I'm going to do for this first problem is, remember, they're stuck side by side, so that means multiplication. So I'm going to go 7 times 6, and I find out that expression is 42. Okay, this one here says, okay, for n, I'm going to substitute 6 for it. And I'm going to do 30 divided by 6, which is 5. So evaluating an algebraic expression is not hard as long as we follow our order of operations and substitute the value in correctly. Here, 13 minus n, my n is 6. Do the math, and I get the answer 7. And the last one here, it doesn't matter if my variable comes first or last. I still am going to substitute it in, and I'm going to get 15 for my answer. Okay, well, the last few examples here are doing it a little bit harder. If you notice, they give me 3 different types of variables, and they've told me what they are here. And now we have to be very careful to make sure we're following our order of operation. So here, I have 36 divided by x. Now, if you notice in my problem, they told me my x was 4. Substitute that in and then finish up bringing down the rest of the information. Now, remember order of operation, division comes before addition. So I need to first do 36 divided by 4. 4 times 9 I know is 36. So 36 divided by 4 is 9. And then I have to do my addition, so my final answer is 11. Here, for this example, I have 15 minus 3y. Now remember that 3y is side by side, so it means multiplication. So to make it easier for myself, I'm going to put parentheses there, reminding me to insert my 7. They're side by side, so I know I need to do multiplication. Now, this is where it comes tricky. People want to go ahead and do 15 minus 3 and then multiply it. No, order of operations says I have to do my multiplication first. So 3 times 7 is 21. Now I have to add a positive 15 and a negative 21 together, and my answer is a negative 6. So be careful with order of operation because it can get tricky. Now the other thing we have to be careful is with powers, okay, with my exponents here. When I substitute that in, I am putting the whole entire number in place, and it's going to be squared. So here my x is 4. So that means, let me finish putting the plus 5 in. So this means 4 times 4, which gives me a positive 16. Add them together and I get 21. Now, let's say instead of a positive 4, let's say my x was a negative 4. Okay, this is where we have to be very careful because this square means I'm truly doing negative 4 times a negative 4. What happens when I multiply two negatives? It becomes a positive. Okay, if you only squared that number, instead of, it should have been 16, instead of getting a positive 16, if you only squared the number, you'd get a negative. So remember, when you're squaring it, you're squaring the whole entire number along with the negatives. If you got negative 16, that would be wrong. So in this case, it's positive 16 plus 5, which gives me 21. Okay, let's do the last example, and we are done for the day. Our last example here says 2, and then I've got z. To substitute my z in, I have a negative 1, and then I have subtract 3. Okay, order of operations says I have to do what's inside my parentheses first. So I need to add these, both of these are negative numbers, and I get negative 4. Once I multiply them together, I get negative 8 as my final answer. Okay, guys, this lesson can look complicated, but it is not. Think it through. Use your order of operations carefully. Watch your negative signs. And if you get stuck on any homework assignments, email me or text me. Have a good day.